Question number 21. Two cells are connected in parallel as shown. Each EMF has a cell has an EMF of 5 volt. 5 volt and an internal resistance 2 ohms. So let us write it down so that it becomes convenient for us to understand. The lamp has a resistance of 4 ohms. 4 ohms. Ammeter is ideal. Okay. What is the reading of the ammeter? So you see there is a parallel network here connected to an external load also. Okay. So in this case what you do is find out what is the equivalent value of this one. Okay. Parallel networks, which will be E total divided by R total is equal to E1 by R1 plus E2 by R2. Okay. So therefore what is E1? E1 is 5 volt divided by what is R1? Internal 2 plus what is E2? E2 is 5 volt once again divided by R2 2. Why did I take plus 5? Because you see this positive and this positive are in the same direction. So which should now be equal to 5 by 2 plus 5 by 2 should be equal to 10 by 2, which is equal to 5. Now what is R total? See, if I consider this resistance over here, then what do I get? I get this as this 2 and 2 are parallel over here, right? I'm not considering this one. I'm looking only at this particular loop over here. I'm not considering this one here. So therefore, so this 2 and 2 are parallel. So 1 by R parallel, it is 1 by R total is equal to 1 by 2 plus 1 by 2, which is equal to 1. So R total should be equal to 1 over here. So therefore, I will write here as E total divided by 1 is equal to 5, or E total should be equal to 5 volt only. Okay, do not consider 10 volt. Many people make a mistake here. Okay, it is not 10 volt. So whenever two cells are connected in series, you can add it. But when they are connected in parallel, you always need to use this formula. Remember this. Okay, E total equal to 5 volt. Okay, now we have got E total and we also got R total, which is equal to how much? 1 ohm. Now we will write the circuit here for this. This circuit now reduces to one battery, which is 5 volt, and one internal resistance, which is 1 ohm, and then connected to this one. So from here the same, you have an ammeter, and after this you have a 4 ohm resistor, and then this is once again connected here. See, this whole thing I have replaced it with this particular part. Okay, this particular part, the whole thing I have replaced it with this part. Okay, now what should I do? Apply Ohm's law. What do I need? I want the current through the ammeter. So this is nothing but current I should be equal to, so this all this is in series circuit. So I can say this should be total potential V divided by 1 plus 4, 5 ohms, which should be equal to 1 ampere. Again, there are some students who make a mistake thinking that these two are parallel. Okay, they are not parallel. The simple reason is because whatever current passes here, the same current pass here, same current here, same current here, same current here, same current here, right? So therefore, they should not be considered parallel. What is the difference between series and parallel? In case of a series circuit, what happens? The same current passes. Okay. In case of a parallel, what happens? The current branches. Which means what? If this was to be parallel, then the current here in this resistor and the current in this resistor should have been different, but that's not been observed. Okay. So therefore, it is the same current. So it is a series circuit. Thus the answer here is 1 ampere, which is answer A. Okay. Let us move on to the next.